In this lecture, we will discuss 8255. 8255 is the programmable peripheral interface. By using this 8255, we can connect the different input-output peripherals to the 8085. In the unit 4, we have seen that whenever you need to connect the input device and output device by using the 3 to 8 decoder or NAND gate decoder, we have connected directly to the 8085. But now if this is nothing but what? If this is the 8085, now in between we have a 8255. Now for this, now totally here 24 pins are there. For these 24 pins, we can connect the different I/O devices. Now this 8085 is connected to the 8255. Here we don't require any decoder circuit to connect the peripherals to the 8255. Using this 8255, we can easily connect. Now this is a general purpose programmable parallel I/O device. Now we can do the program for this 24 pins. We can use it as an input or output. Now here this 8255 is having the 3 I/O ports, and each I/O port is having the 8 pins, thereby what total 24 pins are there. Now to program these ports, we here to program the function of all these 3 ports, it contains a register called control register. Now inside the 8255, we have one register that is called the control register. Now using this control register, we can program these ports. And this control register is having some address, and these ports are also having the address. By using these addresses, we can write the program for the different I/O devices. Now we will see the features. It is a programmable parallel I/O device, and it contains the 24 programmable I/O pins arranged as two 8-bit port and two 4-bit port. Now nothing but what? Here it is contains port A, port B, port C. Now port A is 8-bit, port C is 8-bit. That's why here we are saying as a two 8-bit ports. And two 4-bit port means what? Port C is divided into two parts. One is called as a port C lower and another one is a port C upper. For this it is a 4 pin and it is a 4 pin. That's why here we are calling it as a two 4-bit ports. Now this is port C itself is divided into two. Now here port A and upper port C and port B and lower port C is divided into two groups. Now this port A and upper port C is called as a group A. This is a group A, and this port B and lower it is called as a group B. And it is a compatible with Intel microprocessor families, TTL compatibility. And direct set reset capabilities available for port C. Improved DC driving capacity, and we can operate this 8255 in two modes. One is a bit set reset mode and another one is a IO mode. Again, IO mode is divided into three different modes: mod 0, mod 1, mod 2. Now all these things I will explain in the control word. Now this is the pin diagram. If you see the pin diagram, now here port A pins are there. Here also few port A pins are there. Now this is the port C and port B here and here it is divided port B and two supplies ground and VCC, and here 8 data pins are there and the remaining all are control, read write control logics. Now this is the block diagram. Here we can see that port A 8-bit pins, so is mentioned as PA0 to PA7. Similarly port B it is 8-bit, it is having 8-bit pins, PB0 to PB7, and port C is divided into two parts. One is a port C upper 4 bits and port C lower 4 bits, and port C lower bits are PC0 to PC3 and upper bits are PC4 to PC7. Now this port A and port C upper together it is called as a group A, and port B and port C lower together it is called as a group B. And to control the group A, here the group A control block is there. And to control the group B control block is there. And now data bus buffer, now this is acts like an interface between the data bus which is coming from the 8 to now here it is data bus is going from what 8085. So this data bus is connected to 8085 and data bus buffer of 8255, and this buffer is acting like an interface between this tri-state data bus buffer and the internal bus of the 8255. Now, whenever the microprocessor want to send the data to the output device or microprocessor want to receive the data from the input device, that data will be transferred to the 8085 or to the peripherals through this data bus buffer. Now here one more block is what? Read write control logic. Now to read the data or to write the data, microprocessor will send the read write signal. Now if microprocessor want to send the data to the output device, that time it will send the write signal. Microprocessor want to read the data from the any input device, that time it will send the read signal. Now here A0 and A1. So two address lines are used to select the internal block of this 8255. Now, if you see here, port A, port B, port C, total 3 ports are there. And also, here we have one control register. In this control register, microprocessor will write the control word. So this control word will control the complete operation of this 8255. Now, in which mode we wanted to operate are, so port A is acting like an input port or output port. Everything will be decided by using this control word, and that control word will be sent by the microprocessor and it will be written into the control register. Now, total 4 blocks are there to select. So that's why we are using two address lines. Now, if A0 and A1, if both are 00, it will select the port A. 01, it will select the port B. 10, port C, and 11 for the control register to write the control word in this register. So this for that we are using these last two address bits, and reset is to reset this entire 8255 block. And chip select bit, if this bit is equal to 0, then only this complete block will be enabled. If this bit is equal to 1 means what? It is disabled. Now to read or to write the data into any one of this port, this chip select bit must be 0. Otherwise, if it is a 1 means what? So we can't read and write, or we can't access the data from this register, these ports. Now, this 8255 programmable peripheral interface we can operate in two modes. One is a bit set reset mode, and another one is a IO mode. Now, a control word. Now, already just now we have discussed that in a control register, we put the control word. This control word will control the entire operation, we said. Now, in this control word, this is the control word. This is D0 to D7. This is the 8-bit control word. This last bit will decide that in which mode we are operating. If this bit is equal to 0, we are operating in bit set reset mode. If this bit is equal to 1, then we are operating in IO mode. Now coming to the bit set and reset mode, if we are operating this 8255 as a bit set reset mode, then this bit set reset mode is only for port C. Only port C bits can be set or reset. For that what? The last, in a control word, the last bit must be 0. Then only we are operating this bit set and reset mode. And in this mode, only port C will be operated. Remaining two ports are not available. So we can't use the port A and port B. Now here if you see this is the 8-bit data. Now in this 654-bit digits we are not, bits we are not using, don't care. And coming to the 1, 2, 3. So because the port C total 8 pins are there, to select this pin 2 to the power of 3 bits are required to select the 8 pins. So that's why we are using these 3 pins. If these 3 pins is equal to 0, 0, 0, then bit number 0 will be selected. 001, then bit number 1 will be selected. Like that, if all bits are 1, bit number 7 will be selected. And after selecting these bits, whether this bit should be set or reset, that will be decided by using this last bit D0. If D0 bit is equal to 1, then the particular bit will be selected or set, or if it is 0 means what? Reset. Now, for example, if I wanted to set bit number 1, then I have to choose this 001, and if I wanted to set, then I have to put this bit is equal to 1. If I wanted to reset bit number 7, then I have to select bit number 7 here, and I need to put 0 over here. So like that, we can set and reset the particular bit by selecting the pins like this. Now coming to the IO mode. Now here we can operate this 8255 in three different modes: mod 0, mod 1 and mod 2. Mod 0 is basic IO, means what? All port A, port B, port C can be operated as either input or output mode. Now coming to the mod 1, strobed IO means what? Only port A and port B are operated as a IO, and port C upper can be used as a handshaking signals for the port A, and port C lower can be used for the handshaking signals of the port C. Now here in a total four pins are there. In that, three pins are used for the handshaking, and the remaining now two pins are we can use it as a IO again. Now coming to the port mod 2 bidirectional. In this, only port A can be used as per the bidirectional. Means what? Data flow can be done in both the direction. And at that time, port C bits, in that 5 bits can be used as the handshaking signals for this port A. And the remaining 3, we can use it as a simple IO, or at the time, if the when port A is operated in a mod 2, that time port B we can operate in a simple IO mode, mod 0 or mod 1. If port B is operated in mod 1, the remaining 3 bits can be used as a handshaking signals for the port B. If port B is operated in a mod 0, then that time these 3 pins can also, we can use it for the mod 0. Means what? Simple IO. So this is about the three different types of mods. Now here, if we see the control word, already we have seen that if the D7 is equal to 1, then only we can operate this 8255 in IO mode. So for that, what we need to put 1 for operating in IO mode, and the next two bits 5 and 6 is used to for selecting the group A. Now here group A means what? Port A and port C upper. We can use it as a three different modes. So mod 0, mod 1 and mod 2. By keeping 0, we can operate in a mod 0, 1 we can operate in a mod 1, and 1011 in both the cases we can operate in a mod 2. And coming to the D4 bit is nothing but what? Port A, how we are operating, input or output. So by selecting port, this pin is equal to 1, we are operating port A as an input port. If this bit is equal to 0, we are operating port A in output port. Similarly, D3 is nothing but what? Port C upper. If this bit is equal to 1, input port, and if this bit is equal to 0, output port. Now D2 is for the group B. Now, port B, we can operate in two modes, 0 and 1. So only for two modes, one bit is sufficient to represent. If this bit is equal to 0, mod 0, and if this bit is equal to 1 means what? Mod 1. So port B, how we are operating, that will be decided by using this bit. And now coming to the D1 is nothing but what? Port B. Whether we are operating in input port or output port, this bit will be decided. So if it is a 1, input port, if it is 0, output port. Similarly, the last bit is nothing but what? Port C lower. If this bit is equal to 1, we can operate this port C lower as an inputter. If it is equal to 1, then port C lower as an outputter. All these three bits, three pins. So this is about the IO mode, and we will see in the next lecture, we will see now this 8255 we can operate, we can connect elevator, to control the elevator, we can connect the elevator or we can interface the elevator to the 8085 traffic lights and A to D, D to A connectors, any LEDs, stepper motor. Now, for all these applications, we will use this 8255. Now, few programs we will discuss in the next lecture.